Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, let's talk about three real-time challenges that DevOps engineers face with their Kubernetes clusters in the production environment. Now, this is very important because a lot of times when you give the interviews, interviewers ask about the real-time challenges that you have faced while working on Kubernetes. And if you cannot explain the answer to this question, there are chances that interviewer might feel you don't have real-time working experience with Kubernetes. So please watch this video till the end. I will take three real-time challenges that DevOps engineers face. Almost every DevOps engineer face these challenges in their organization. I will explain them as detailed as possible. Let's start with the most common challenge that almost every DevOps engineer face in their organization, that is resource sharing. So when you have a Kubernetes cluster, it can be in the dev environment, it can be in the staging environment, or it can be in the production environment. How do you allocate the resources of this Kubernetes cluster between multiple development teams, right? End of the day, each development team will not have their own Kubernetes cluster in the production environment, right? You have multiple microservices in your organization deploying to the same Kubernetes cluster, or you have multiple project teams within your organization. But when you talk about production level Kubernetes cluster, all of them are using the same cluster. So as a DevOps engineer, how do you organize this Kubernetes cluster? How do you share the resources and allocate the resources of this Kubernetes cluster between the development teams or the project teams? So one obvious answer that you might be talking about is, Abhishek, what I will do is I will create multiple namespaces, right? So if you are talking about, let's say, a e-commerce application. So in the e-commerce application, assume you have a web team which is taking care of, let's say, the login, logout, all the front end work. And then you have probably the payments team, which is taking care of the payments related application, microservice. Then you have, let's say, the transactions team or the delivery shipment team. So for each team, you can say that, Abhishek, I will be creating the namespaces. So here comes the actual challenge. When you create namespaces, let's assume this Kubernetes cluster altogether, which has multiple worker nodes. All the worker nodes together, let's say, has 100 CPU and 100 GB RAM. So for purpose of making it easy, assume there are 5 worker nodes on this Kubernetes cluster, and each worker node has 20 CPU and 20 GB RAM. Just for the purpose of easiness, usually it will be like 32 or 64 GB RAM per one worker node. So now there is 100 CPU and 100 GB RAM. And if you, let's say, do not split the resources between the namespaces. So you have just created the namespaces on this Kubernetes cluster, and people started deploying their services onto this Kubernetes cluster. So payments team, if this is their namespace, they started deploying their services onto this namespace. Other people have deployed their services onto the namespace. Now, assume there is one service or some services of the payments within the payments namespace. For some reason, they are leaking memory. What does leaking memory mean? That means they are consuming memory more than required for some reason. there can be some issue with this application, or the payments team has not performed the performance related testing of this application, and whatever the reason it is, it started leaking the memory and it started using most of the resources of this Kubernetes cluster. So ideally, these applications, let's say, have to consume 2 GB RAM, but because of the leakage of memory and because multiple requests are coming to these services, what it started doing is it started using more amount of resources. Probably it took 32 GB RAM. So these three services, instead of taking 6 GB RAM, just for example, they started consuming 32 GB RAM. And what is the result of it? The other services will start seeing less number of resources on this cluster. So if this namespace itself is taking 40 GB RAM, then all the other namespaces will only be left with 60 GB RAM. Because of this, maybe one of the service in any of the namespace might not get the resources and it might get crashed. It might go into crash loop back off because of the OOM killed issue. Why it get OOM killed? That is out of memory killed error. Because of some other application in some other namespace is consuming more number of resources. Now this is the responsibility of the DevOps engineer to make sure that you provide only the required amount of resources to a particular namespace. So how do you do that? How do you provide only required amount of resources to a particular namespace? So for that, what we can do, just a second. So as a DevOps engineer, to solve this issue, which is the most common thing in many organizations. So for each namespace, we have to come up with a resource quota. So even I faced this challenge in one of my previous organizations. So that's why I'm trying to address this, and probably if you explain this in your interviews, interviewer will be very much convinced that you have real-time exposure. So for each namespace, you allocate the resource quota. Now, what does resource quota mean? If you are not aware of this concept, I will explain very quickly. Resource quota is a limit that you apply to the namespace. So beyond the allocated resource quota, if I say this namespace has to consume 15 GB, I mean at the most, the limit, the resource quota that I set for this namespace is 15 GB, then all the services within this namespace, it can be 5 services, 10 services, 20 services, or even 100 services, together they cannot consume more than 50 GB RAM, 15 GB RAM, right? So resource quota is a limit that you set on a particular namespace. So because of this, now the namespace will only start using the provided RAM and CPU. Resource quota can be of both the CPU and RAM. You can set the limit with respect to CPU and with respect to RAM. So as a DevOps engineer, what you will do is you will talk to these development teams, ask the payments team, okay, what is the required amount of resources that you require for your all the microservices? They cannot say 40 GB, they cannot say 60 GB, right? What they should do is at their end, they have to perform performance benchmarking, right? So when you approach the development teams, they have to do something called as performance benchmarking, and using the performance benchmarking, they have to come up with an ideal number. So they will say that, okay, Abhishek, for this particular namespace, we need 15 GB RAM and 15 CPU. So that will be the resource quota that you will set on this. And probably this namespace will say we need 20 CPU and 20 GB RAM. this namespace might say 25 CPU and 25 GB RAM. Of course, as a DevOps engineer, you can question them. You can ask them that for 10 microservices, probably why would you need so much thing? But end of the day, if the development team is performing the performance benchmarking as per the standards of your organization, you cannot question them beyond that point. You should allocate them the required amount of resources. You can set up a meeting with them, ask them the questions, but end of the day, they will provide you the required amount of resources. So perfect, you got the required amount of resources. If all the namespaces together is exceeding 100 CPU and 100 GB RAM, now again it is your responsibility to scale the cluster. Probably you can add one more worker node and make sure all the namespaces get required amount of resources. Okay, Abhishek, one challenge is solved. So as you said, I will set up the resource quota, and because of the resource quota, the challenge with namespaces is solved. But what if I tell you this is only 50% of the challenge? Now the other 50% that is left is, once you allocated, let's say 15 CPU and 15 GB RAM for this particular namespace. Okay, there are 5 services in this namespace. Assume, and you have allocated 15 GB RAM. Again, the challenge is there is one microservice, as I've explained previously. This particular microservice is leaking memory. Now, what will happen is, previously it impacted the entire cluster, but now it will impact one particular namespace. So the impact is still there, but the impact is only restricted at this point of time to one particular namespace of the Kubernetes cluster. So the blast radius is reduced. So blast radius is basically a term that we use in the industry where something is causing an issue. What is the blast radius for it? In this sense, the blast radius came down from cluster to namespace. So using resource quota, you have reduced the blast radius as a DevOps engineer, but still it is restricted to a particular namespace. For that, what you will do is you will set up resource requests or resource limits is the important thing actually, because resource request is basically saying what is the minimum amount of resources that are required for your pod to run. But in our case, we are talking about resource limits. So resource quota is the limit that is set on a particular namespace. Similarly, resource limit is a limit that you set on a particular pod. Okay. We will also do this practically in one of the troubleshooting sessions. We are doing a troubleshooting playlist. I will show practically how to set up resource quota on namespace. It is just one single command, but still I will show you. And similarly, I will also show you how to set up resource limits on a particular pod. I think we have already covered this, but I'll try to show again. So it is just adding few fields to your pod resource or your deployment resource. But what is the result of this? Previously, we restricted limit on a particular namespace. With resource limit, we will restrict limit on a particular pod. So again, as a DevOps engineer, you will go back to the development team and you will take the performance benchmarking of each application or each microservice. Okay, you will keep the data of the performance benchmarking of each microservice, and when you deploy through your scripts, through your CI/CD, or when you write the YAML files for this microservices, what you will do this time is for each microservice, you will set up resource limits. On a rough scale, for easy example, let's assume you have 5 microservices. You will say 3 GB RAM for this, 3 GB RAM for this, 3 GB RAM for this, and 3 GB RAM for this. This is the worst way of saying, I know, but just for the easy example. In general, it will not be like that. Probably this microservice might need 8 CPU, 8 GB RAM, whereas this microservice might only need 1 CPU and 1 GB RAM as per the performance benchmarking. So you will just take the details and depending upon their thing, you will allocate that. Now, after that, even after allocating 8 GB memory for this particular pod, if it is leaking memory, then you will simply say that, okay, we have already created the namespace for you. We have created resource limits for you. If one of your pod is causing an issue and it is impacting the other microservices within your pod, then you have to handle that. Who has to handle that? The development team. Now, how will you help the development team with that? That is our scenario number 2. I'll go to that point, but before that, I want everyone to understand this scenario. This is a real-time challenge where for the namespaces, you will use resource quota, and for each pod, you will set up resource limits so that the blast radius is now only reduced to one of your pod. Let me draw this again and try to explain before we move to the next scenario. So previously, when you have this Kubernetes cluster, if there is a pod, the blast radius was the entire Kubernetes cluster. You have the namespaces, of course, but the pod started consuming resources from the cluster, from all the nodes of your cluster, because of which the entire cluster has become your blast radius. Once you set up resource quota, the blast radius has come down to a particular namespace. Now, because of this pod, which is leaking memory, what happened is the other pods within the namespace might not get the resources. Okay, so blast radius is for that particular namespace. If you set up resource limits on this particular pod, where you say out of 15 GB memory, only 8 GB memory is allocated to this pod. After it started consuming 8 GB memory, and if it goes beyond that, what will happen is the pod gets crashed. Now this pod will get crashed. Previously, if you did not have the resource quota, some other pod in some other namespace might get have crashed. If you don't have resource limits, probably any other pod in this namespace might have got crashed. Once you set up both the resource quota and the resource limits on that particular namespace, sorry, on that particular pod, now the blast radius has come down to that particular pod itself. So this pod is getting crashed and this pod is going into out of memory, right? With this, we have completed our real-time scenario number 1. So you can explain this the same way in the interview. And what is the outcome of this explanation? You will simply say, as a DevOps engineer, when I joined the organization, there was a cluster which was shared between multiple development teams. So because of one of the pod which is leaking memory, the entire cluster was impacted. We did not know which pod is going down, why is it going down? So I mean, which pod is going down in which namespace because of out of memory. So what I have done as a DevOps engineer, I have set up the resource quota, I have set up the resource limits on that particular pods of the namespaces, and because of which I can identify which pod is creating the issue, and I can identify the blast radius coming down to one particular pod. Now let's move to our scenario number 2. It is just a continuation of the same scenario. Now, in the previous case, I have explained that, okay, once you set up the resource quota and resource limit, you have identified which pod is leaking memory. And what you have done is you noticed that this particular pod is going into OOM killed, which is a crash loop backoff. As I have explained, crash loop backoff is just a status. It is not an error. The actual error is OOM killed, that is out of memory killed. When you do kubectl get pods, you will see the status as crash loop backoff. But when you do kubectl describe on that particular pod, you will see that the crash loop backoff is because of OOM killed. Now, in this case, what you will do? Okay, as a DevOps engineer, you have noticed that one of your pod went into OOM killed. This is another very important real-time challenge that you can explain to the interviewer, or interviewer themselves might ask you, how will you resolve the OOM killed issue on a particular pod, or how do you resolve the issue of a pod going down because of the memory issues? So what you can say is, okay, I have noticed this issue on our production environment or on our dev or staging environment. I have noticed that one of my pod is going down because of the OOM killed issue. I have already set up the resource quota. I have already set up the resource limits. Still the pod is going into OOM killed even after giving 8 GB RAM as per the performance benchmarking of the development team. So what I have done is, let's assume this application is a Java application. This microservice is a Java microservice. So you can explain the interviewer that I went to this pod and I have shared the thread dump and also the heap dump. So you will log into the pod. For example, thread dump is taken using the kill -3 command. Okay, if you go to the pod and if you execute the kill -3 command, you can get the thread dump. If you execute a jstack command, you can get the heap dump. So instead of explaining the commands, I'm just explaining for your easiness. It depends upon the programming language to language. In some programming languages, you cannot even take the thread dumps directly. But if you take Java as an example, instead of complicating by explaining the commands, you can simply tell them that I went to this pod and I have taken the thread dumps and heap dumps, and I have shared this thread dumps and heap dumps with the development team. As a DevOps engineer, probably you cannot do much more than this. What you can do is you can just share them the thread dump, heap dump. They will understand which thread or which part of this microservice is leaking the memory, and they will perform their analysis. They will create a Jira ticket, or they will come up with a root cause analysis, and they will say that, okay, this was the issue, let me fix it and let me come with a new version of the application. Okay, and you will deploy the new version of the application on the cluster again. So this is your scope as a DevOps engineer, where when you identify a out of memory killed microservice, remember you must have set the resource quota and the resource limit. If you haven't set the resource quota and resource limit, you might be seeing out of memory killed because of any other microservice consuming more resources on the cluster, and this particular microservice or pod not getting the resources. Probably the pod created on the cluster beyond 200 MB, the pod was not getting the resources, so it got crashed. So only if you have set resource quota and resource limit, which is the primary thing as a DevOps engineer, still if you see the OOM killed on a particular pod, you will just go to that particular pod because you have already provided it required resources as per the performance benchmarking. You will take the thread dump and heap dump. Different programming languages have different commands. In some programming languages like Golang, probably you cannot take the thread dump, heap dump directly. It is a different scenario. But let's cover the most common ones. Like in Java programming language, you will just take thread dump and heap dump and share it with the developer. This is your responsibility. After that, if you still want to know what developer does, so they will analyze the threads. They will try to see why a particular thread is leaking memory, and they will perform some analysis in depth on that thread, come up with a new version and share it with you. So this is our scenario 2. This is how we handle the OOM killed error. So you can explain this scenario as well after explaining the first scenario. Now let's move to the third scenario, which again is a very common one. You can explain one of the challenges that I have faced in my organization is upgrades. Interviewer will always be convinced if you say upgrades, and the other two scenarios as well, because they are very, very common. Almost every DevOps engineer in every organization will face the challenges like our scenario number one, which is resource splitting or sharing the resources. OOM killed. Probably there is no organization where a DevOps engineer might have not seen the OOM killed error. Similarly, there is no organization or there is no DevOps engineer who might have not performed upgrades. It's a very common one. Today, if you are using K8 1.29 on your Kubernetes cluster, you will have to upgrade to 1.30 at some point of time. So you have to go through the upgrade process. Of course, I have not created the upgrade related video on my channel. I will do that very soon, where step one, right from what is required, what are the prerequisites, I will cover each and everything practically by taking a EKS cluster or a Kube ADM cluster, whatever most number of people will benefit from. I will take one of these scenarios because there are slight changes in the steps, but I will try to explain the complete upgrade process end to end. But for now, at a high level, you can say one of our challenges was upgrades. So, it is always challenging as a DevOps engineer. When it comes to upgrades, we have to be very careful. So how do we overcome this challenge is we have prepared a very detailed manual. This is how you can explain the interviewer. As a DevOps engineer who has experience in upgrades, what I have done is I have created a manual with detailed steps. Our Kubernetes cluster, you can explain that is a KubeADM cluster or EKS cluster. Because I have performed couple of upgrades till now, I have prepared a end-to-end manual with detailed steps where I have documented things like how to take backup before performing the upgrade, how to go through the release notes. People miss this step always during the interview, which is very, very important. Whenever there is a new version of any particular application, it can be Kubernetes, it can be Argo CD, it can be Istio, anything, they have a release notes, which is very important to read, because there might be a change in 1.30 of the Kubernetes cluster. Without reading release notes, if you perform the upgrade, your cluster might go completely down. There might be a breaking change. There might be a feature that was upgraded from beta to stable. Who knows? You might not be using that feature and that might be deprecated also. Sorry, you might be using a feature that might be deprecated also. So you should always read the release notes. Of course, there might not be that significant impact of your cluster going down, but still, if you don't read the release notes, you might run into some adverse effect. So I have created a manual with detailed steps which explains how to take the backup of resources, how to read the release notes, what exactly are the points in the release note that might impact our cluster. I have noted that down. Then you will say, I have divided steps for control plane components and the worker nodes, the data plane components. In the control plane components, I have detailed the steps on how to start with etcd, and then how to upgrade the version of Kube API server, then how to upgrade the version of scheduler. What are the steps? What is the order? I have noted down. And then in the worker node or the data plane, I have explained how to first The steps are basically, let's say you have multiple worker nodes. What you usually do in the organization, these are the real-time steps. First, you drain a node. Okay, when you have 3 nodes, first you will pick up a node and you will drain the node. Draining means you will give this particular node time to move, or the scheduler time to move the pods that are running on this particular node to a different node or to different nodes of your Kubernetes cluster. Once the pods are moved and the node is empty, they don't have any resources running on it, no microservices are running on the node, then you will make the node unschedulable. You will do both of them at the same time. Okay, so you will taint the node, or you will cordon the node. These are the terms. Or you will make the node unschedulable, and now there will be no services that will be scheduled on this node. So almost kube scheduler will only have these 2 nodes that are working. So you will disconnect this node. What you will do is you will upgrade the kubelet to the new version, and you will install other new packages that are required on this particular node, and then you will bring this node up. You will join the node again back to the Kubernetes cluster, and this time you will remove the unschedulable taint and any other taints that you have applied. So now this node is running with 1.29, this node is running with 1.29, but this node is running with 1.30. Again, you will keep both of these nodes active, and you will cordon this node, make it unschedulable, drain the pods. Again, you will perform the activity. It will come to 1.30, and similarly, you will perform on this. You can explain the upgrade challenges that you have. You can say it is very challenging in your environment. You have prepared a detailed manual, detailed steps, and this is how you have performed the upgrades. So these are the 3 real-time challenges that every DevOps engineer face in their organization with respect to Kubernetes cluster. Even if you explain 70 to 80% of what I've explained, you can easily convince the interviewer that you have real-time working experience on Kubernetes, and you are really good at solving the Kubernetes challenges. Thank you so much for watching today's video. Do let me know definitely in the comment section, how did you find this video? I'm trying to give you as many real-time things as possible. I'm also doing Kubernetes troubleshooting series. So most of the Kubernetes real-time things are covered on this channel. I've recently done a video on Istio as well. Next, I will be doing video on advanced things of Kubernetes. So your feedback is very important for me. I look forward for the feedback in the comment section. Thank you so much for watching it. See you all in the next video. Take care. Bye-bye.